Hello, everyone, and welcome to High Achievers Chemistry Hub. In this lesson, we are going to learn about the 6 changes of state of matter. Matter can exist mainly as a solid, liquid, or gas, and it can change from one state to another when energy is transferred. The 6 changes we will learn are melting, boiling, freezing, condensation, sublimation, and desublimation, also called deposition. As we go through the lesson, focus on what happens to the particles and how their energy changes. By the end of this lesson, you should be able to identify all 6 changes of state and describe the direction of each change. You should also be able to explain these changes using the particle model. We will look at the difference between boiling and evaporation, because this is a common examination question. Finally, you should be able to recognize that changes of state are physical changes. This means that the substance itself does not become a new substance. Only the arrangement, movement, and energy of the particles change. Before looking at the individual changes, let us understand the particle model. In a solid, particles are packed very closely together. They cannot move from place to place, but they vibrate around fixed positions. In a liquid, particles are still close together, but they have enough energy to move past one another. In a gas, particles are much further apart and move rapidly in random directions. So, when a substance changes state, we are really changing the movement and arrangement of its particles. Here are the 6 changes of state that we need to remember. Melting is solid to liquid. Boiling is liquid to gas. Freezing is liquid to solid. Condensation is gas to liquid. Sublimation is solid directly to gas. And desublimation, or deposition, is gas directly to solid. A useful way to remember the energy changes is that melting, boiling, and sublimation involve energy being absorbed. Freezing, condensation, and desublimation involve energy being released. Let us begin with melting. Melting is the change from a solid to a liquid. When we heat a solid, its particles gain energy and vibrate more strongly. At the melting point, the particles have enough energy to overcome some of the forces holding them in fixed positions. They can then move past one another, and the solid becomes a liquid. Energy is absorbed during melting. A familiar example is ice changing into liquid water. Notice that the substance is still water. No new substance has been produced. Next, we have boiling. Boiling is the change from a liquid to a gas. When a liquid is heated to its boiling point, particles throughout the liquid gain enough energy to escape from the liquid. This is why bubbles form inside the liquid during boiling. The bubbles contain the gas or vapor and rise to the surface. Boiling occurs throughout the liquid, which is an important point for examinations. For a given external pressure, a pure substance boils at a definite temperature. For example, water boils at about 100 degrees Celsius at standard atmospheric pressure. Freezing is the opposite of melting. It is the change from a liquid to a solid. When a liquid is cooled, its particles lose energy and move more slowly. Eventually, they become arranged in a more fixed structure, forming a solid. Energy is released to the surroundings during freezing. Water provides an interesting exception. Ice is less dense than liquid water, which is why ice floats on water. This unusual property is very important for life in aquatic environments. Condensation is the change from a gas to a liquid. When a gas is cooled, its particles lose energy and move more slowly. The particles come closer together, and attractive forces allow a liquid to form. Energy is released during condensation. A simple example is water droplets appearing on the outside of a cold glass. These droplets are formed when water vapor in the surrounding air loses energy and condenses into liquid water. The water does not pass through the glass. Sublimation is a special change of state in which a solid changes directly into a gas without becoming a liquid first. The particles in the solid absorb enough energy to escape directly into the gas state. Energy is therefore absorbed during sublimation. A familiar example is dry ice. Dry ice is solid carbon dioxide, and at ordinary atmospheric pressure, it changes directly into carbon dioxide gas. Iodine is another substance that can show sublimation when heated. Desublimation, also known as deposition, is the opposite of sublimation. It occurs when a gas changes directly into a solid without passing through the liquid state. During this process, particles lose energy and become part of the solid structure. Energy is released. A good example is frost. Under suitable conditions, water vapor in the air can change directly into ice crystals on a very cold surface. So, gas can become solid without first becoming a liquid. Let us compare boiling and evaporation, because students often confuse these two processes. Boiling occurs throughout the liquid, whereas evaporation occurs only at the surface. During boiling, bubbles of vapor form inside the liquid. Evaporation does not produce bubbles. Boiling occurs at the boiling point for a given pressure, while evaporation can occur at temperatures below the boiling point. Evaporation is usually a slower process. So, if an examination question asks where the change occurs, remember, boiling occurs throughout the liquid, while evaporation occurs at the surface. Now let us bring all the energy changes together. When a substance changes from solid to liquid to gas, or solid directly to gas, energy is absorbed. These processes are melting, boiling, and sublimation. When a substance changes from gas to liquid to solid, or gas directly to solid, energy is released. These are condensation, freezing, and desublimation. Remember that during a phase change, the energy is mainly involved in changing particle arrangement and overcoming or forming attractive forces. A phase change does not create a new substance.